is an alkyl halide right there, iodine is sitting on the carbon that has only one carbon substituents, right? One carbon substituents. But it's a bit big, but it's a one carbon substituent. So this one we classify as a primary alkyl halide, right? That one, this carbon is the beryllium iodine. That one has a two carbon chain. So that is a secondary alkyl halide. So based on what we just talked about, primary alkyl halide should be better substrate to the SN2 reaction than secondary, right? But in this example, it's an opposite. The reason is that even though this is a primary, this primary position is right next to T-butyl groups. T-butyl, if just becomes too big, it has an influence even to the next positions. So this is kind of exceptional cases, but we often use this example to see whether you understand this concept or not. So you really want to remember this exception for the test. Hopefully. But anyway, most of the time, if it's not a T-butyl, yeah, then primary will be definitely advanced to the secondary. But this is a primary next to the tertiary T-butyl groups there. So that is exceptional cases. And because of the T-butyl groups, the nucleophiles cannot get through there. So that's why it's worse than secondary, even with the primary. If this becomes a one more carbon in between, then there's just normal primary and there, but it's just this is just right next to T-butyl groups. That's the one it pulls it out. All right, so those are the concepts, but the question that you probably have to answer is not going to be asked, yeah, just give me the body, what's going to be happening, right? And it's simple as that. Otherwise, you simply just replace it and that's will, answer. So we normally make you choose what you're going to do. So where do you think reaction will happen? What do you think will happen? First of all, we have a nucleophile right there, right? This nitrogen has a lone pair, that's a nucleophile. It's kind of a good enough nucleophile there. We got alkyl halide, but you can see that there's two different halogens there. One is a bromine, the other is a chlorine. So which halogen is going to get replaced? Is a bromine will get replaced or the chlorine will get replaced? Then the question is, what should be considered to sort them out? So you can see that this bromine is sitting on the tertiary carbon, this chlorine is sitting on the primary carbon, right? So I think that degree of substitution, the steric hindrance around the alkyl halide will be the factors. So less sterically hindered one will go through the reaction faster. So between these two, which one will be replaced? Chlorine or bromine? Chlorine, right? Because they're sitting on the primary carbon. So you're going to use the concept to solve the problem. This should be a pretty simple question, but I always have the students value with this one, so when they do this to you, so you cannot forget. We've been talking about degree of substitution, so I'm pretty sure that now it will be almost like customary for you to just check how many carbons that carbon have. So let's say this is a secondary, right? This is a one carbon, two carbons in there. The secondary bromine right there. But look at this chlorine, that's only having a one carbon there. So that's a primary, isn't it? So if you do the reaction, then the same nucleophile is going to replace in chlorine or the bromine. The state could be less demanding, right? The lower the degree of substitutions are better for the SN2 reactions. This is a secondary, that's a primary, if we can tell primary, the secondary bubble bonds. So that's a primary. So you probably like to answer, this will be replaced by that, just like the previous example. My answer is no. So why does it suddenly go to the more substituted positions? Yeah, because this chlorine is bonded with the double bond, the bond, sp2 carbon any any halogen bound to the sp2 carbon is not the subject of the reaction in these chapters, right? So it looks like they are primary, but this is not your concern because they are bonded to the double bonds, and that's an sp2 carbon. Halogen bond, they are more stronger. It's difficult to break it by these reactions. So there's only one group halogen we can react with, which is the secondary layer.